Hello everyone. Today it's interview about a book Fundamental Software Architecture with Mark and Nil. I am Grisha, Java dev and host of Between Breakers, and with me, my host Nikolai Golov. Koda, hello. Tell a little more about yourself.
So, long story short, I'm working for as an architect all my life, all my career, almost 20 years. I never worked as a developer. I started as an architect at the beginning. I'm mostly focused on the data platforms, data engineering, big data stuff. But I also participated in big projects of like separating monolith into transferring to microservice architecture, switching to event-driven architecture, and all this stuff. In some big companies. Now I'm working in a pretty small California-based startup called ManyChat. And also in parallel, I'm a university teacher in university in Barcelona. I have a course about databases, all types of databases, all questions connected to databases. Like it's a three weeks intensive of 15 days by 3 hours. That I suppose you understand. It's pretty intensive one.
Fantastic.
But for some reason, my students like it. So let's go to you. Can you introduce yourself, please?
Yeah, Mark, tell a little bit about you.
You bet. I've actually been in the industry for almost 37 years now. 27 of those as a software architect, and about the past 10 years of my career has been devoted almost primarily to microservices. And it's been helping companies migrate to microservices, but also greenfield. So it's been quite a wild ride. Let me just say that. But I did actually about the past 5 to 6 years, I've made a shift in my career to actually do less kind of hands-on consulting and more kind of training, both at conferences, workshops, and also kind of private and also public training. I just kind of felt, and this transition, like I said, happened about 6 years ago, that I was on a particular development team, and I said, I've amassed all of this knowledge over 30 plus years, and it's not really doing the industry much good being buried on a development team, which I loved the development team. It was a great project, a great team, but I said, I want to start kind of spreading knowledge more than just kind of being an individual contributor. So I still am in the field. I'm still hands-on, but that shift has changed from a 70-30 to almost like a 30%, 70% now. So, and I'm so much enjoying it. Nikolai, I'm so jealous about your teaching at university. That's one of my actual retirement goals, as a matter of fact. Right now, I travel way too much to have the consistency of schedule to be able to do that. But it is one of my passions, which was probably part of my retirement plan some year.
The questions can really ruin all your picture of all your understanding of architecture. They can ask you questions which you're absolutely not prepared to.
That's right.
All right, I'll go next. I'm Nil Ford. I've actually only had 2 jobs in the software field. I started at a company and worked there 11 years, started as a developer, worked my way up to CTO of a small training consulting company. And then I left there and joined ThoughtWorks as an architect, and I've been there for 17 and a half years now. So I'm unlike most people in the IT world that move around a lot. I never move around. I've had 2 jobs in the last 27 years. So I'm stick around a lot. I work for ThoughtWorks, which is an international consultancy. So I get to see a lot of very interesting problems. And what I'm doing when I write books is leveraging one of the superpowers of consultants, because we get to see lots of different solutions of problems and things that work and things that don't work and the conditions they work in, et cetera. So that's very much what I've been doing. And that's part of my title, which is Meme Wrangler. Finding memes and wrangling them is kind of what we do when we're writing books. And so it's a great way if you're paying attention to things that work and things that don't work. Being a consultant is great because you get exposed to a huge number of different things all the time. But you shouldn't talk about a superpower without also talking about kryptonite. The typical kryptonite of consultants is that we don't get to get systems where from inception through development and maintenance for years and all that, because we're most often involved in creating stuff or untangling problems that got created at some other point. So, but it is great if you are trying to understand, the software development ecosystem as a whole, to be able to see lots and lots of examples of that and things that work and things that tragically do not work.
Fantastic, thank you. It's also, you can notice why we love read book, because book it's compilation of experience, and fantastic how you can see on some problem with other side. Thank you for your sharing. And before we start, I want to make a little small talk, because small talk help our audience know you better. My first of all question may be simple, not good, but I love ask all. What your favorite programming language? Mark, what about you?
Oh boy, out of probably the 12 plus programming languages that I've used in my career, my favorite still remains C language. I kind of remember, well, we all remember our first love, and C was my first love. It was the first programming language that I actually used kind of professionally. I dabbled in a lot of, Forth, Modula 2, of course, Fortran, Pascal, Ops 5, and the list goes on. But C was the first one where I did some serious programming. And I'm still very fond of it. Now, the reason is because I see it as, well, out of all the languages out there, probably the sharpest knife. Neil may argue with me, but I see it as one of the sharpest knives in the drawer. It's just something that is complex. I have to manage my own memory, of course, but also it allows me to get into the machine, as opposed to have that higher level of abstraction that a lot of the languages do today. So although I really love a lot of programming languages, Erlang would be one of them, Scala would be another, C still kind of remains probably my favorite language.
Yeah. Thank you for sharing. For example, my first love it's be JavaScript, but no, I don't like JavaScript. Yeah. Neil, what about you?
So if JavaScript's your favorite language, then you must really like tough love, because that's got some very inadvertent sharp edges. So I actually have two favorite programming languages as well, but for very different reasons. My favorite one to actually write code in to get quick stuff done is Ruby, because it is so powerful and it's so friendly. In fact, it's so developer friendly that it's so friendly that you'll accidentally cut your foot off and it'd be perfectly happy about that. So you have to be careful. It's a sharp knife. But it's a sharp knife in a slightly different way than C, because C is sort of like a sharp knife with rotating blades, whereas Ruby is just a single sharp knife that you can't get in quite as much trouble with. But it's so pleasurable because things just work. But it's so friendly that it leads you down bad paths because of convenience. So that's my favorite convenience language. My favorite language from a pure engineering standpoint is Clojure, because I love Lisps anyway, and Clojure is the best of many worlds, which is taking advantage of the JVM and a really, really beautiful, elegant language design by Rich Hickey. And so for engineering happiness, it's Clojure, and for developer happiness, it's Ruby.
Fantastic. Thank you. And the last one small talk questions, and what inspired you to work in IT?
I can start that one. I actually started as a journalism major and was one of those that went through a whole bunch of different majors. I majored in genetics for a short amount of time, and then I settled on mechanical engineering, and I actually got my 2-year degree in physics and started working toward mechanical engineering until I realized I really, really hate mechanical engineering. I got through the statics and the dynamics class. And it's like, if I do this the rest of my life, I'm going to be miserable. So I took a step back and thought, what are the classes that I really enjoyed? And this is back before I owned my own computer, and I was actually writing out source code by hand and then going to the computer lab and typing it in. And I was dreaming of coding. And I realized, that's the thing that I really love is software and coding. So that's when I switched over to computer science and got my degree eventually in computer science. But it took me a circuitous path. But fortunately, I found the thing that I loved. My wife claims that at some point my career and my hobby just sort of merged together into one big thing. And it's been there ever since.
It's fantastic. Yeah, you look like who enjoy IT and who enjoy work. It's beautiful and fantastic. Mark, what about you?
I have played around with computers as long as I can remember, all the way back from high school, and that goes into the 70s, with my first computer being actually the Timex Sinclair, and that was just kind of fun to play around with, hooked up to a TV with a little membrane like keyboard, and then graduated to the Commodore 64 and then the 128 and all of the traditional TRS-80 and all of those. But what really got me into kind of IT, I started my career actually as an astronomer. I was working at Braeside Observatory in Flagstaff, Arizona, right on Mars Hill. And we were charged with basically looking for black holes, variable stars, binary star systems and stuff. And so we had a kind of an observation program that we did. And the telescope, and this is a fairly large observatory, but back in that day, very little was automated. So we had to actually hand crank the dome so that the slit in the dome window would follow the slew of the telescope. And we'd have to manually change all of the filters when we're looking at a particular star system. So we basically said, well, this is silly. The other astronomer was also really interested in computers. And so we started automating all the parts of the observatory, the dome, we created stepper motors to actually change the filters automatically. We wrote programs to do this, and the automated reduction of all that data. And that just got me more interested in computers than astronomy. So unlike Neil, who kind of merged his hobbies, I decided, I think I want astronomy as a hobby. And I'm really passionate about computers and programming. And so that's when I made the transfer over to pure programming and software development work. So I still love astronomy, but I'm passionate about both.
I never, ever do mechanical engineering as a hobby. So.
By the way, astronomy, I suppose it's pretty popular secondary tasks for software engineers, because I suppose a lot of participants of this call, they know Oleg Bortunov. He's contributed to Postgres. He is one of the authors of JSON support and Postgres. He is also he's a scientist. He is also in the field of astronomy.
Oh wow! Huh.
He also started it this way.
Wow.
Yeah. Thank you for your sharing. And let's start to talk about the book. First of all, questions. It's why did you decide to write this book, and for who?
Well, it's funny. Neil and I were actually on vacation, and we've both spoken at conferences since the early 2000s on topics of architecture. But we were on vacation together, and we were just kind of musing that there's really no book out there that was a comprehensive view of software architecture. All of the aspects, technical aspects, the soft skills, the techniques. And so we started looking at the material that we had and the things and the experiences that both of us had in architecture. and said, you know, we ought to write that book. And 7 years later, it was published. So that was a long journey.
But it's actually a good example of iterative design, which we talk about in software, but you can do that for material, book material too, because we first started looking at it, it's like, it's impossibly big to write about. There's just too many things, there's too many facets. So we started this filtering process. Well, that has to be there. Well, you know, maybe that part of that can be there. And we actually started teaching the material in various guises online, but this is mostly in person at conferences, workshops, et cetera. And as we would teach the material, we would see the stuff that was most important and things you can set aside. So that 7 years was very much an iterative design process to kind of narrow down the things that ended up in the fundamentals book. And it changed our perspective on a few things. For example, we used to call everything architecture patterns, but then we realized at some point that the name topologies are really different than the patterns. And that's where the style idea came from versus patterns. And so just like in iterative code, iterative book writing helps you refine your ideas before you write them down. And so that 7 years was a lot of iteration before we finally managed to write it all down.
Yeah. And speaking of that last piece, Neil, I remember we would both separately do conference sessions about these architecture patterns, which we now call styles. And people would come up afterwards and say, hey, that was great. I love seeing event-driven and service-based, but why didn't you talk about CQRS? Or why didn't you talk about streaming architecture? And that's when all of a sudden I realized, naming matters. And it was, well, those aren't really patterns. Those are patterns, but these are higher level patterns. And I realized, whoops, we're using the same name for describing the overarching structure of the application versus the lower level building blocks that are still structural, like CQRS or event forwarding or workflow event, all of these different architectural patterns. And those are building blocks that can be used in each of these styles. And so that's when we decided to kind of rebrand it. Fortunately, and we lucked out, Neil, because we kind of made this discovery before we published the book. So that was fortunate. But before we move on, one of the other things that I did kind of want to mention about this was when Neil and I decided to write this book, one of the other observations that we made is that there were some books about architecture and stuff, but a lot of them were theoretical in nature. And one of the differentiators that we wanted to do in this book was really to make it practical experience. In other words, Neil and I both drew off of, 30 years each of experience in the industry, things that worked and didn't work, and that we happened to both individually refine. And that's one of the big differentiators, at least in my mind, of our book versus a lot of the other architecture books out there. There's little, if no, theory in this book at all. It's all practice.
Yeah. Your book, it's so useful, and all engineers can find the better thing for system and understand how make application better. Also, maybe when you write a book, maybe you can cooperate with some IT project and make some thing from them.
Yeah. And as a matter of fact, before that, I do want to make sure that that didn't come across as kind of dissing any other architecture book, because there are some great architecture books out there, ones that have influenced my career as an architect. So when I said that our book is differentiated because it lacks theory and it includes all practice, I didn't want to make sure that I said that other books are all theory and not practice. The thing that Neil and I noticed is that each book that we read was one aspect of software architecture. It wasn't a comprehensive guide for how to become an architect. And that was one of the major differentiators. Yeah, I just wanted to make sure that I cleared that up because, like I said, there's a lot of really good books in architecture that have influenced my life.
It is exactly place when I wanted to add that you mentioned microservices. So have you talked with Chris Richardson? Have you worked with him? How you estimate his book?
Oh, yeah. Oh, absolutely. Yeah. And as a matter of fact, we, Neil and I, on our hard parts, software architecture, the hard parts actually drew off of some foundational aspects that Chris Richardson actually identified in the microservices patterns book, which were the transactional sagas. And great pattern, great concept of kind of bringing things together. But we kind of used that and leveraged that to further that kind of concept. So, but he was also part of a speaking or a conference tour that we spoke at for some time. So we've both have been collaborating and also know Chris fairly well. So yeah, but yeah, that's he was like Sam Newman, kind of on the forefront of identifying some of these common patterns that exist within microservices.
Mm-hmm. Mm-hmm. Sorry. By the way, I worked together with him on those microservice projects, and I had experience with sagas. And we still haven't reached this part of your books about microservice architecture, but I hope it will be interesting because sagas, it's like completely it blows your mind.
Mm-hmm.
Yeah, I have. Neil?
I was going to say that's the really the second part of our software architecture, the hard parts book, is the untangling of all the forces and sagas. So, but you're right, it's a very, very complicated thing, and it took us a while to figure out how to untangle all that.
Cool. I have some funny format. It's called short review. We make it after all book, and also I going to inject our interview some questions from this short review. It's questions about if you have 1 hour, which chapter you're gonna read from your book.
Interesting. You know, it's funny. Both Neil and I have read our book probably about 100 times, I guess, Neil, because of the whole writing and editing process. And Neil and I both chose chapters that we had a little more expertise or interest and passion in writing, and ended up pretty much almost 50% exactly between us. But we would read each other's chapters to do edits before it went to the publisher. And then, of course, there's many cycles of reviewing. So yeah, I would say we've read our book several dozen times over, if not 100. But I'd have to say, for me, I kind of enjoyed writing the space-based architecture chapter. I got so excited and passionate about writing that the first draft of that was over 80 pages long. And I realized, wait a minute, we're kind of limited to around 450 pages. And I had to trim that chapter up significantly. That's how complex that architecture style was. But I've had a lot of experience with space-based. And I always make the joke, it's my favorite architecture style because I used to be an astronomer, so hence space. But of course, it has nothing to do with that. But there's a lot of complexity and a lot of mathematics. And that just was a very enjoyable chapter for me to write. And so I'd have to say, I don't know if I really have a favorite chapter, but that one in and of itself kind of stands out for me as one that was most enjoyable to write.
You know, and I have to put myself in the audience spot because it's a fundamentals book, and so we actually understand all the fundamentals. So I wouldn't read this book to learn something new necessarily, because I know all the stuff that's in this book because we wrote it. If I were going to read a chapter from this book, I would almost certainly read reread the orchestration-driven SOA chapter because I would like to dance on its grave some more, because we don't like that architectural style and we mostly say bad things about it. So I would rejoice in the bad things that we said about that architecture and to discourage people from using it. But if I was looking for the chapter or the part that had the most unique perspective. So one of the things that Mark and I wanted to do, that Mark alluded to earlier, is write a software architecture book that didn't have any of the past 20 years of baggage. So what if you looked at software architecture as if it were a brand new thing that we had just invented yesterday? What would we change definitionally? And the architecture characteristic stuff, I think, is the biggest divergence from what previous people had done. So if I were looking for the most unique perspective in this book, it's probably the first part around architecture characteristics and how we identify and how we think about those things.
Yeah. Thank you for sharing. I think our audience going to reread this chapter and make something new for they. Also, I have the last funny questions. Someone gonna say what it's the main questions of our interview. Why on the cover parrot?
That's actually something that O'Reilly does for all of their books. They have a thematic animal that they choose, and you may have noticed or not that they keep the same set of animals for different books, and so software architecture books all have birds on them. And so we got the parrot for this one, and we didn't actually choose the parrot. That one was actually delivered for us, but we actually did get to choose the one on the Hard Parts book, and it's actually Mark's wife who made the great suggestion there, right, Mark?
Yes, because due to the success, actually, of the fundamentals of software architecture, they actually gave us an opening to say, listen, we'll let you suggest your animal. And so Neil wanted a dragon. He said, that's easy. We'll take a dragon.
It's a kind of bird, right? It flies.
It's kind of a bird. It flies. It's got wings. And his rationale for the dragon was that we were slaying all of the hard parts of architecture with this book. Well, O'Reilly immediately came back and said, no. And that was your only shot. I'm like, no, wait. And so I was telling my wife about this. And of course, she is a birder. She's into birds and stuff. And she said, why not a woodpecker? And I'm like, a woodpecker? Why would we use a woodpecker? And she's like, well, from what I understand, you're kind of pecking away at the hard parts, the outer shell of that tree to get to the gooey inner center of everything, because that's really what feeds you. And I'm like, oh my gosh, that's exactly what we're doing in that book. And so we suggested it to O'Reilly, and they went with that suggestion. So it was amazing. But the parrot does have significance of the software architecture book, our fundamentals book, because that particular parrot is actually known to build the most intricate architecture for a nest. Its nest architecture, if you will, is one of the most intricate of all birds. And so they kind of made that association with the architecture, superior architecture of the nesting, to put that on our cover. So that's the specifically why a parrot.
And that specific parrot, as it turns out.
And that specific parrot, yes. Yeah.
Okay, so now let's switch to my questions. So we are estimating this book is not just a theory, but as a possibility of application in architecture for real projects, for real companies, for real ties. Also, in some cases, as a career path for people who just want to develop himself or herself as architect. That is my first question. What do you think currently, according to your experience, what is most popular question for an architect? Please help us to design a new system, or help us to solve this piece of garbage, rewrite, refactor it so it shall work perfectly as modern system shall. So what do you think?
Well, so you got to realize that we both have confirmation bias because we're both consultants. So it's rare that we are brought in on beautiful greenfield projects to work on things. And it's very common that we're brought in to help untangle train wrecks. And so our professional experience is much more with existing systems, but that shouldn't skew people's opinion about how much of one thing is being written versus the other. I would say that I think there is a much higher percentage in the world of software that's undergoing mutation than new software being created, because software that does useful stuff tends not to go away. It just tends to get modified and bent and mangled and keeps going. I'm probably nobody on this call is old enough to remember bulletin board systems before the internet. But there were bulletin board systems where you could actually dial up with a modem and go to programmer specific bulletin boards and, learn stuff and download programming languages. And I still remember they always had a sign off screen. And when you left the site, you'd get the sign off screen. And I remember one of them from a bulletin board. This is from the 1990s that said, you may be able to see forever, but COBOL still prints your paycheck. And you know what? That's still true today. That as much as they wrote that COBOL code in the 1950s and thought, this will be gone in 5 years, it's still there because it still does useful work. So if you look at the total percentage of software in the world, only a tiny percentage of it could be new stuff because there's so much existing software that still runs our world as we know it now. So,
but you know what, Neil, I'm gonna actually twist that a little bit. Semantically, because a lot of work that I do is conversions from things like COBOL or RPG. And it's interesting because it's existing functionality that, let's say, prints your paycheck or rebalances accounts or manages portfolios. But it's moving from COBOL to a new platform, a new language, a new architecture. And so I tend to qualify those as greenfield projects. It's not new functionality, but it's an entirely new system. And I do quite a few of those conversions. So yesterday, Neil and I were playing the semantics game between restructuring versus migration versus refactoring. Well, Neil, now I have another level and layer, because it's conversion. A conversion is less of a migration part. In other words, it is a complete, we're not even leveraging, all we're leveraging are business rules. That's it. There's no code, there's no platform. Everything is entirely different. And I wonder if that's different than migration. We'd have to think about that one, Neil.
but you're almost getting into something else that Mark and I incidentally talked about this last weekend, the ship of Theseus problem. So the ship of Theseus, left port, and then gradually they replaced every part of it. And then 20 years later, when it came back, every single part had been replaced. Is it still the ship of Theseus? If every part has been replaced during its journey, is it still the same thing when it showed up? So if you have all this business functionality and every single implementation detail has changed, is it still the same thing or not? That's the philosophical question of doing migrations versus conversions.
Yeah, it really is. Yeah.
Yes, a favorite question of my students, why they are still using Oracle. It was created 50 years ago. Why? And why it is so popular? Why it is not going away, replaced by new stuff? I say,
it solves real business problems. Full stop. That's it. That's all it has to do. That's all it has to do to survive for a millennium, is to solve real problems that businesses have. So, people in the software world love shiny new things. One of the things I say about software developers is the best thing about software developers is they love new software. And the worst thing about software developers is that they love new software. Not everything has to be new to be effective and work great. And so we have this tendency to everything new is great and everything old must suck, but that's not necessarily true. So, but as frustrating as it is to deal with some, legacy dinosaur like Oracle, the reason it has survived is because it's still providing value.
Actually, it's interesting. I think there's two reasons. You're right. Well, now I'll make it three. So yes, it's the whole thing about providing the business value. It's also the level of maturity from a technology and capability standpoint. It stands out from others, quite frankly. It really does. But you know what, Nicola, there's another really interesting reason why it's so popular. And that is because, at least in my experiences, we seem, and I say we being technologists, IT, seem to have blinders on in terms of the other possibilities that exist for data. And it becomes a go-to automatic de facto way of, quote, storing and modeling data. And albeit, I'll just throw out a number, 60% of all the kind of data and relationships is really that relational database nature. Data's related, and we love that organization. It's why the n-tiered layered architecture was the de facto standard for almost 4 decades. 4 decades, because it was a go-to. There were all these other possibilities, but we got comfortable with it. It was just a natural fit. So I think that third reason is, quite frankly, Nicola, something that we should, and I think have a responsibility to challenge. Neil and I do this all the time with architecture. Not everything has to be microservices. There are other architecture styles and hybrids and solutions that are actually more appropriate for most of the situations we see. And I do think this is a call to action, I guess is what I'm saying, is to understand and study those different kinds of databases, whether it be columnar or graph or KV or document or any of the new SQL, edge databases, sharding databases. All of these options exist. The maturity level is not to where something like Oracle is, but those provide sometimes better capabilities for our particular problem than a traditional RDBMS. So I love this question, because this really should be a call to action to understand and appreciate that there are other ways to model data that could be more appropriate. And it's not only the modeling, but it's also what we're trying to optimize. Are we trying to optimize on reads? Are we trying to get high data integrity, high scalability, sheer raw performance? This is not a one size fits all. So, okay, enough of my soapbox.
Well, you can actually see that perspective shift happening in real time with me and Mark, because he and I wrote the fundamentals book, but then as we've been dealing with architecture, we've realized how important data has become. And so we added 2 data specific authors to the Hard Parts book, which was Pramod Sadalge and Zhamak Dehagani, experts in operational and analytical data correspondingly, because of how important data and the data considerations have become in projects now, particularly distributed architectures.
Yeah. Yeah.
Just for an audience, she is a creator of data mesh approach. It's a main source of arguing between data engineers. Okay, so about the question about Oracle. So first of all, I understand that the question was interesting, and I definitely will not ask any questions about CAP theorem, because I understand that it will be dangerous, because it's time. And answering my students about this question, I usually say them that I will answer in this question about Oracle 3 weeks of my course. And the short answer is because Oracle survived 50 years of quality assurance.
Exactly.
And the next question for you about shiny stuff, which you have mentioned. We know we all have shiny stuff. We have a lot of companies, a lot of fancy startups, which are organized in the horizontal manner without hierarchy. A lot of them don't have architects. A lot of them have just developers. They have cross-functional teams. They use agile. The idea is move fast, break things. What do you think? How architecture shall be embedded in such modern teams?
I will absolutely dispute one of your statements when you say They do not have architects, because they do, they just don't have anyone identified in the architect role. Anyone who's making long-term decisions is making an architecture level decision, regardless of what they're called in that organization. So this is actually a question we get a lot, because I spend a lot of time in the Agile ecosystem. So here's the analogy that I go to all the time for this. Let's use buildings as a tortured metaphor here. So if I want to build a doghouse, I don't need an architecture. I don't need a blueprint. I need lumber and a hammer and nails. If I'm going to build a 50-story office building, I've got to do some planning. I've got to think about elevators and electricity and plumbing and the number of people who are going to be in that building and the traffic flow and all those sorts of things. So you can't get away without it. Similarly, if I'm building a little website to register kids for a football team, I don't need architecture. I need a little framework I can download and just piece it together. If I'm building a highly scalable, highly available, highly performant website to manage concert ticketing, I have to do planning for that. I have to do architecture for that. So one of the important distinctions that Rebecca Parsons made to me years ago was this distinction between emergent design and evolutionary architecture. So one of the things that somebody recently came up to me and said, hey, in the design world, we're taught that you start with a roller skate and then design that into a bicycle and then that into a car and then that into a lorry. But you can't do that with architecture, because every time you did that, you'd have to fundamentally rewrite everything. You have to know that our target is a lorry and that we have to do some planning. So agile architecture doesn't mean no architecture. It means no just wasted architectural effort, but you still have to do planning and you still have to do architecture to build sophisticated things, because you have to be able to support that level of sophistication.
Yeah. Well, and also I want to dispel two myths about software architecture. The first myth that I want to dispel is this continued belief that I still see at times when we talk about this agile piece about architecture stable. It has to be defined up front. That's the first myth I want to dispel. To Neil's point, we have to do planning. We have to do some level of structure, a scaffolding. But like Agile, we don't know a lot about the project yet. In Agile, we code based on learning more about it. And what I have actually witnessed, observed, and also experienced is that the role of the architect actually becomes more important in Agile than in other types of methodologies. And when I say important, I mean the involvement of that architect, that tight collaboration with development teams, and that architect being heavily involved in the full life cycle. Because the other myth I want to dispel is that architecture is the stuff that's hard to change. And one of the things that I see and that would be Neil and I, but we being the collective group of architects in this world now, are trying to do is to make architecture easier to change, because it does. Business is changing faster and at a faster rate than it ever has before, ever. And while businesses can now get a level of agility to change direction based on market conditions, based on all sorts of world events that are happening, we in IT start to become the bottleneck. And that's largely due to the complexity and the difficulty in changing a software architecture. So one of the things I like to try to say is in Agile, architecture is iterative and evolves just like your software does. And this sometimes is perceived by a lot of product owners and business stakeholders as the fact that I, as an architect, don't know what I'm doing. I see you didn't get that right, or you didn't get that right. And there still is this perception that architecture is this big, stable structure like a building that has to be defined before we can do anything. And we're not building buildings. We're building software. And Neil's right. It's a tortured metaphor because what was our quote, Neil? All metaphors eventually break. I think that's what we had in our book.
Well, yeah. That's the model. All models are inaccurate, but some are useful.
That's right. Yes, yes, yes. But Neil talked about a roller skate. That's very similar to Gall's law, Galls. Now, Gall's law postulates the following. This is from John Gall, that all complex software systems originate from a simple system that evolved to that level of complexity. Any complex system that started out initially as that complex system will fail to achieve its goals and generally go back to a simpler system, which then evolves. And this is the whole idea of this iterative architecture concept or practice.
Now, there are a couple of follow-ups on that. One of my favorite Mark quotes is actually in our evolutionary architecture book, which is all architectures are iterative. Agile just realizes this and does it sooner, which is to say that you always iterate on design and architecture. Agile just realizes that's going to happen and makes that part of the process, not something that surprises you after the fact. And the other thing about Mark said about stability, Rebecca Parsons, one of my co-authors in the evolutionary architecture book, when we first started talking about that concept in 2017, she said that people would come up to her after conference talks and claim that she was being professionally irresponsible to suggest that you could evolve the architecture, because the architecture is supposed to never change. That's the bedrock, that we never change in our systems. And of course, that's ridiculous, because as we need new capabilities, as the business and ecosystem markets change, we have to change our architecture too, which is the whole premise behind evolutionary architecture. She doesn't get that a lot anymore. What she gets now is, okay, tell us how to evolve architectures, not it can't evolve, because they've realized that it has to evolve, just like our businesses and domains do.
Yes. So let me go to the next question. It's a dangerous space, a space of personal opinions, because I'm trying to combine different questions in one.
The answer to the question then is Emacs. Oh, sorry, wrong question.
Okay. Yes, but you understand that you got the point. First of all, currently we live in the world of pretty powerful tools. If I do like the data platform, I often ask companies how many data do they have, and then they answer. I say it will fit here. You don't have problems. You don't have you don't need Hadoop. You don't need Snowflake. You don't need any complex architecture. You just forget. First question is that maybe for a lot of services, a lot of systems, complex architecture is a little bit obsolete. And to augment this question, you have mentioned that we are moving to agile. What architecture you personally think is better suited for those agile development, that then at the beginning you have obsolete resources for all your tasks? You expect changes, you expect nothing except changes. You still don't know what changes, but you understand that everything will change. And in such conditions, what architecture you personally will prefer? Personal opinion.
Well, so I wrote an entire book about evolutionary architecture. So that has nothing to do with the architecture style that you choose. It's the mechanics of how you implement that architecture. So we talk about this idea of architectural fitness functions. And in fact, you can police the structure of the architecture you have to make sure it doesn't change negatively over time. So, but a lot of this is driven by things like how much time and money do I have before I have to hit market? Because if I'm in a startup, I'm not going to build a really elaborate microservice architecture that's going to take a lot of time and effort, because I'll never make it to the market and I'll never get a chance to try it. So I will build a modular monolith, but with governance protections wired into the architecture so that I can evolve it into a microservice architecture at some point. So the idea of evolution is you don't have to start in a particular place. You have to have the mechanics in place for whatever architecture you choose to allow you to do evolution.
Yeah, this is a tough question, because one of the key common answers, and for the most part, it's correct, is it's less about the specific architectural style, but it's more about architectural modularity. The more modular our architectures, the more adaptable they are to change, and the higher the levels of agility, that ability to respond quickly to change, which includes maintaining your code, testing your code, and deploying your code, all three of those. Now, Neil's right. Modular monoliths is a monolithic architecture style that supports a level of architectural modularity. And that architectural modularity comes from the fact that it's not separately deployed units of software that make up a modular monolith, but rather it's structured by domain. So it makes it easier to identify, locate your changes. There's less coupling overall because of that. And it's safer deployments, less risk, a little more completeness of testing on that. And the transition, or I should say the migration step next, would be something like service-based architecture, which again still allows for monolithic data, but those services we create, which is distributed architecture, are known as domain services. All of the domain functionality is encompassed in a separate deployment unit. So essentially what we're doing is we're taking a modular monolith, single deployment unit, a single assembly, and we're taking each of the domains that it consists of, and we're making those as separately deployed units of software. And then the third level would be to take those particular domains that need higher levels of agility, scalability, elasticity, and move those to microservices, which gives us even a higher level. So Neil's right, it depends on a lot of things. One of the things it depends on is the nature of what you're building. A startup that needs to get the product out the door as fast as possible, microservices is generally not appropriate because it's pretty complex, it's very costly, requires containerization, DevOps, Kubernetes, all of the tooling. And that kind of infrastructure is not free, it's not cheap, and it's not easy and fast to get right. So it's really about modularity. It is kind of the common core answer to that question. Yeah. But the reason I said it's a hard question to answer is because a lot of times it also depends on the nature of your changes and also your team structure. Now, when you mentioned Agile, I make the assumption that teams are organized by, cross-functional teams maintaining specialization, and that a majority of your work is domain-based. In other words, each team is aligned with a particular domain or portion of functionality. But suppose that a majority of your work and tasks that lay ahead of you and in the future is constantly replacing your user interface or constantly replacing your data. Boy, that kind of change with the architecture styles I just mentioned is painful. And that's where the layered architecture, technically partitioned, or even space-based, which is technically partitioned, really comes into play as the ability to respond quickly to those kind of changes. So as you can see, Nikolay, the reason that question's so hard is because of all the influences, external influences on that architecture, but all of the things that architecture influences.
But there's an interesting follow-up here that's something that Mark and I have been ranting about both lately, about this idea in software architecture of a best practice. So most people say that best practices don't exist in software architecture, particularly not in the structural design part. And it's exactly for the reasons that Mark is getting to right there, because the idea of a best practice is that when this situation comes up, I can just turn my brain off and always do this thing because it is the best practice. If it were a better practice, that would at least give you a little wiggle room, but it's not. It's the best practice. So we've got to do that. Just turn your brain off and do that thing. But the problem in software architecture is that nothing applies to that. You have to do the trade-off analysis over and over again. So your question about, well, you were basically asking, what's the best practice for building agile systems? There is no best practice. You have to do the trade-off analysis over and over and over again and look at all those forces that Mark was talking about: team structure, problem domain, time to market, cost, all those things go into it. And so that's one of the reasons that software architecture is so difficult, because you cannot distill all the best practices of software architecture into a single book or a single place, because you have to do the trade-off analysis over and over and over and over again.
Great. So thanks a lot. Our schedule is pretty tight, so I suppose a block of questions about career path of architects, we will not have time for it. But we have a question from YouTube. Do a person who wants to become an architect needs to have a developer background to succeed in this area, or no? What do you think?
Well, I think Nikolai should answer that question more than two of us, because you're the one who's actually done that, right? So the real answer to that question is, I don't think you have to have a development background. What you need is breadth of experience. This is one of the things that Mark and I talk about that distinguishes architects, is technical breadth versus technical depth. Because technical depth means you're an expert at some technical thing that you know all the important things about it. Technical breadth is about exposure to lots and lots of different things. And I think that's the valuable perspective, because the thing you're doing as an architect is constantly doing trade-off analysis. Well, to be able to do trade-off analysis, you have to know about trade-offs between different things, and that really requires breadth. And so certainly a technical background, but I think that breadth of experience would be more important than just developer experience.
Question from Ruslan. Be fast, please.
Hello. So I have little questions. What do you think, what's the best techniques, language, or approach for visual describing architecture now? Such as email, C4 model, or box and arrow.
Mark and I have resisted choosing a particular standardized diagramming technique, and I've always just done ad hoc boxes and lines. And it's not because we don't like any of them. We just don't think they're complete enough, because the problem you run into is, well, UML is pretty deprecated, but C4 is quite popular. Archimate and Archie are quite popular. The problem you run into is our ecosystem changes so fast that any standard you choose, you immediately have to start customizing it for the way the ecosystem changes. And now you don't have a standard framework anymore. You've got a customized standard framework. So the thing for us is the base framework really useful as it is, so that we can customize it versus starting from scratch? We thought about using one of the standard formats for our books, but decided we'd rather just do the cleanest, simplest diagrams we possibly could for the book, which ended up just being lines and boxes.
Yeah. Now that said, though, Christian, I have grown very, very fond of Excalibur. It's become well, close to one of my favorite tools within a context. A lot of the work that we do now and in the past, well, 3 years plus has been all online and at home, and we still have to collaborate. And I think that's given rise to a lot of these kind of online drawing tools like Draw.io, Excalibur. The reason I call out Excalibur is not only is it a refreshing kind of view, but it gives you a draft view. When you look at the diagram, not only does it look actually kind of interesting and nice, and I love just the graphics, but it looks like a sketch. And that is so important when you are iterating or working on an architectural solution, because all too often, if I'm to use Visio or Omnigraphal, which is what I usually use, the diagrams look pretty formal. And if you show anybody that diagram, their first impression, oh, well, this is done. This can't change. And I love that aspect of the sketchiness of Excalibur. But outside of that, I'm with Nil. Archimate, I applaud. the open group, and I do applaud them for Archimates as an attempt to try to form some sort of standard. Where I see that falling apart is, unlike building architects, we have a whole variety of viewers. Developers may look at my architecture diagrams, operations, DevOps, business stakeholders, a product owner, different views of the same architecture solution. And I have yet to find any tool that offers that kind of flexibility. So that's why I really like free-form drawing tools. Yeah.
Thank you. Thank you.
Thank you.
Time over and our interview is ending. I want to say the big thanks for Mark and Nil, and it is fantastic and we really appreciate it. And this is fantastic book, yeah, what we gonna recommend all engineers. And also by all traditional, we want to make a photo with you. It's be fantastic. Yeah.
I was trying to figure out, Gregory, which language. I think our book has been translated into 8 different languages now, and I've got them all right behind me here. And I'm like, oh, which one should I pull up? But I'll just bring up the first traditional.
Yeah. All look at the your cam and smile. Yeah, it's fantastic interview. Yeah. It's really be fun, many good stories, and just little one photo by phone. Yeah, good interview and good company. Yeah, really thank you. It's fantastic. Yeah, and really appreciate it. Thank you for all what be attending to us, for questions. It be interesting. And one more thanks, big thanks from our community to you, Nil and Mark. Thank you very much. And have a nice day. All bye. Yeah, thank you. It be fantastic interview.
Right.
Yeah.
Well,
bye
thank you for having us.
Bye.
Yep. All right. Bye-bye.
Bye bye. Yeah.